In this video, I'm going to look at the linear programming problem in your homework about the farmer. The hard thing for me about linear programming is that there's always so much going on in the problem. They're always talking about a couple of variables, a couple of constraints, and don't forget, the major point of linear programming is that we're either going to try to maximize or minimize something. So when they give you the word problem, we have to kind of figure out what all is going on in there. So I start by reading it. It says a farmer can plant up to 8 acres of land with wheat and barley. She can earn $5,000 for an acre of wheat and $3,000 for an acre of barley. She can only use 10 gallons of pesticide, but it takes 2 gallons of pesticide for every acre of wheat and only 1 gallon for every acre of barley. What is the maximum profit for the farmer? That last sentence is actually my big key because that's what I'm trying to find. I need to maximize the profit. And if I go back to the beginning, this sentence right here talks about how I make money, which means this must have to do with maximizing profit. So this is what I'm going to use in the end to write my equation for max profit. Before I get to that though, I want to figure out, well, what are my variables, my x and my y? Since it's $5,000 for wheat and $3,000 for barley, that tells me that the wheat and the barley are my x and my y. I could have gone here as well where it says the variable, let x stand for the numbers of wheat, y stand for the numbers of barley, but it is important we start to think about that. So as I write my constraints and my profit expression, I'm going to use x and y for wheat and barley. Now, the other two things that this problem refers to is acres and pesticides. So those two things must account for my constraints. That's what's keeping the farmer from covering the earth with her best crop. So you can see we give you some guidance. We say, okay, what's the area constraint? So I go back, and this is the sentence that talks specifically about acres. Now this is sometimes one of the harder ones for students to write because all it says is the farmer can plant up to 8 acres of land with wheat and barley, which means the total amount of wheat and barley together, I keep saying barley, is x plus y. So I don't have anything attached to the x and y, it's just x plus y, but if it's up to 8 acres, that means this must be less than or equal to 8. For pesticides, it says she can only use 10 gallons of pesticides. So that's the most, but it takes 2 gallons for every acre of wheat. So in this case, 2 gallons per acre of wheat and 1 gallon for every acre of barley, so plus 1y. And it's up to 10, so it should be less than or equal to 10. Now, real-world constraints is something that won't come necessarily from the problem, but we just have to think about it. In most real-world situations, negative numbers don't make sense. So the amount of wheat we can actually purchase, it can't be negative. So the wheat, which is x, has to be greater than or equal to 0. And the real-world barley, which is my y is greater than or equal to 0. Now, in order for me to figure out this problem, I need to be able to find all of the points that create the boundary. Now, these are my two easiest things to graph. So, x is greater than or equal to 0 is a vertical line here. So really that restricts it to the right of that line, which means it's in the first quadrant. Y greater than or equal to 0 would be a line here, and again, we graph up. Now, we talked about if it's in standard form like these are, how we can just plot the x and y-intercept. The problem is I need exact points, so I'm actually going to convert these into slope-intercept form. So in this case, I get y is less than or equal to negative x plus 8, which means 5, 6, 7, 8. I have a y-intercept at 8, and my slope is negative 1. So I'm going to plot exact points so that I know where the point of intersection is in the end. It's less than or equal to, so it's a solid line. And now we're back to graphing inequalities. We can use a test point. I'm going to use 0, 0. Is 0 less than or equal to negative 0 plus 8? Is 0 less than or equal to 8? Yes, which means from here, I would shade down here. So if this was all my restrictions, I would just be restricted to that triangle. However, now I need to take into account the pesticide constraint. 2x plus 1y is less than or equal to 10. Again, that's 1y, I just need to subtract 2x. So now I have y is less than or equal to negative 2x plus 10. I start at 10, and now my slope is negative 2 over 1. this is going to be the one critical point. And this is another. Okay. So I have my graph, but once again, I test 0, 0. Is 0 less than -2 times 0 plus 10? Is 0 less than or equal to 10? Yes, which means I also shade this way, which would be, oops, this way to the graph. And so when all is said and done, this region down here with 4 sides is the region we're looking at. But remember, we're talking about boundary points. And so I actually have 4 of them. The 4 possible options that could maximize my profit are 0, 0, which doesn't make sense. We're going to test it this time. You don't usually need to test it. I could sell 0 acres of wheat and 8 acres of barley. The 0.08 is key. I could sell 5 acres of wheat and 0 acres of barley, or looks like 2, 6 is that point. So 2 acres of wheat and 6 acres of barley. So we do some scaffolding for you, and we give you the table at the bottom. So I'm going to go ahead and put those 4 points we just found in here. 0, 0, 0, 8 we found, 5, 0, and 2, 6. But in order for us to figure out the profit for each of those, we have to go back to the very beginning and find that sentence that they said about maximizing my profit. And they said that she can earn $5,000 for wheat, so that's 5,000x, and 3,000 for barley. So the expression I'm going to use for my profit is 5,000x plus 300y. And I'm going to plug each of these ordered pairs. So 5,000x plus 3,000y. I'm going to plug each of these ordered pairs in for that. So I do 0 times 5,000 plus 0 times 3,000. Obviously, I get $0 for that. We knew that wouldn't be the case, but we tried it. 0 times 5,000 plus 8 times 3,000. And that gives me $24,000. If I sell 5 acres of wheat, that's 5 times 5,000 plus 0 times 3,000 gives me 25,000. So that's slightly better. But if I sell 2 acres of wheat, that gives me 2 times 5,000 plus 6 acres of barley, 6 times 3,000. I add those up and I get $28,000. So you can see that this is in fact my best option. So to maximize my profit, I want 2 acres of wheat and 6 acres of barley. And that's how we do linear programming.